So for this part of the video, we will be talking all about the inelastic collision. So inelastic collision is different from the elastic collision because when you try to check after the collision, the bodies now have the same velocity. So let's have a sample problem here. So we have here before the collision, the green car has a mass of 1,500 kilograms moving 60 meters per second to the right side of your screen. It is now in contact or moving towards each other. We have here the blue car having a mass of 1,000 kilograms, but this time it is moving 45 meters per second to the left side of your screen. So that's before the collision. After the collision, when both cars collided with each other, they now have the same velocity. Now, it is indicated here that the velocity is now towards the right side of the screen. So we will expect a positive velocity. That means moving to the right side of the screen. So the very first thing that we're going to do is still just like in the elastic collision, we will write the general equation. That means we have the P, let's say P sub G, meaning this is the momentum of the green car before the collision plus the momentum of the blue car before the collision is equal to the momentum of the green car after the collision plus the momentum of the blue car after the collision. So, after that, you go back to the origin of the formula of momentum. That means when you have PG1, that means you have the mass. Sorry, it's so big. So you have the mass of wait, yun, the mass of the green vehicle or the green car is equal to the velocity of the green car before the collision. Sorry, you multiply it pala plus the mass of the blue car times the velocity of the blue car before the collision equals m sub g, the mass of the green car, times the vg 2 plus mb VB1. Okay, so let's have a quick recap. So when you have here mg is the mass of the green car, vg1 is the velocity of the green car before the collision, plus mb, the mass of the blue car, times the vb1, the velocity of the blue car before the collision, is equal to mg vg2, that means the velocity of the green car after the collision, plus mb vb sorry, this should be VB2. Okay? So that means this is the velocity of the blue car after the collision. Now, when we try to go back here, when we try to go back here, after the collision, the green car and the blue car now, they have now common velocity. They have now one common velocity. Ibig sabihin, their masses will not change. Why? Because wala man siya nakuhaan, wala man siya nadugangan. So their masses is still the same. But they have now one common velocity. So our expression after the collision will now change into okay, so let's just simply delete this. Okay, so that will just simply turn into your mass of the green car plus the mass of the blue car multiplied by your velocity, no? That common velocity, that final velocity. Still, this is your momentum. Diba? The formula for momentum is basically mv. But in this case, the masses that we're trying to consider are the masses of the green car and the blue car. And then the velocity that we're considering here is the final velocity, which is based on the based on the picture, they have now one common velocity. Okay, so in this case, this will now be our expression. So we are tasked to solve for the v sub f, or the final common velocity. So very simple, all we need to do is divide both sides by mg plus mb to extract the v sub f here. Then we also divide the other side by mg plus mb. Okay, so we can cancel this out just like the other one. So we have here mg v g1 plus mb v b1 over the mass of the green plus the mass of the blue car equals the final velocity. So just like what I said in the previous video, all we need to do is to arrange this so that it will be acceptable in the mathematics world. So very simple. We simply exchange their positions. No? So in this case, we have now the V sub F is equal to mg V G1 plus mb V B1 over mg plus mb. After this, you simply substitute all of the given. So mg, or the mass of your green car, is 1,500. So you put there 1,500 kilograms multiplied by the velocity of the green car before the collision. Remember that the green car is moving to the right side of the screen. So we will have here a positive 60. No? So you put there positive 60 meters per second plus the mass of the blue car, which is 1,000 kilograms, multiplied by the velocity of the blue car before the collision. When you try to check the picture, the moving car, the blue car is moving to the left side of the screen. So we say negative to, negative 45, no? So lagay natin dito, negative 45 meters per second divided by the mass of the green car, which is 1,500 kilograms, plus the mass of the blue car, which is 1,000 kilograms. So, just like what I said in the previous video, you do the operations on the numerator muna so that it will not be very difficult for you. So in this case, we have now here 1,500 times 60. So when you get your magic calculator, that's 1,500 times 60. You will now have 90,000. Then, kilogram times meter per second is simply kilogram times meters per second plus 1,000 times negative 45. So 1,000 times negative 45, that will give you negative 45,000. Then kilogram times meter per second is simply kilogram times meters per second divided by yung nasa baba, 1,500 plus 1,000, that will give you 2,500 kilograms. So in this case, you do the operation now on the numerator. So you have 90 kilogram times meter per second. Since this is negative, so this will be simply converted into, or converted, this will be written as this one. Okay, so you will now have here a subtraction. Okay, so subtraction tayo dito. So in this case, you have now 90 minus 45,000. You will have 45,000. Then you still have the units, kilogram times meter per second. So you have kilogram times meters per second divided by 2,500 kilograms. So in this case, you simply need to divide 45,000 by 2,500, and your magic calculator will show you that's 18. Then, in this case, we can cancel out kilograms because that would just be equal to 1, leaving now the only unit meters per second. So this is meters per second. This is now the final velocity. Anong ibig sabihin nito? It simply means that after the collision, the green car and the blue car, they now have the same velocity, which is 18, no? That's 18 meters per second, which is positive. So that means both of the cars are now moving to the right side of your screen. So this is 18 meters per second. Okay? So I hope you will do your part in trying to check if it's really true that the total momentum before the collision should be equal to the total momentum after the collision. So that's it. That's how you solve or deal problems related to this type of collision.